I'm pretty sure that Francois now will help us to understand science maybe a bit better, because he will show us maps, and this is something, of course, which is much more easy to understand. Francois, maybe take the mic already. I again try to find with the computer.
Thank you. Yeah. So my talk today is about a modeling approach that we developed in D2 Aqua in Denmark, and together with colleagues from Sweden and Germany. And it's taking the point from the fishery perspective there, and then to see how we can do some impact assessment, socio-economic impact assessment. So it's about a model-based approach, because we have a lot of interaction between different data layers. And then if we bring all these data layers all together in the same framework, for example, we have conservation areas that are Natura 2000 sites, protecting relevant habitats. We have a growing use of the sea, such as windmill farms. We have fishing vessels harvesting the underlying resources there that are, for example, herring, sprat, and cod. So we would like to conduct an impact assessment on what will be the effect on the individual fishing vessels' economy there in terms of effort displacement. And then this is a picture of the footprint of the fishing vessels in the Skagerrak and Western Baltic areas, and this is basically the swept area by all these fishing activities, and it's to show you the potential heterogeneity in the spatial structures and patterns that can emerge from those activities. And for example, if we break different activities into several activities, so we have a footprint from some crustacean fisheries that will be likely different from the demersal Senos fishery or the trawlers. So it's important to acknowledge the heterogeneity there of this aspect. But then if we further scale down our analysis, we have very fine resolution data that can be used to directly inform MSP issues there. So for example, for the Danish and Swedish and German activities, we can see some patterns that fishermen are going to have some preferences and spatial structure in their effort allocation, because they have different priorities and motivations that should take into account when we try to do an impact assessment there on their socio-economy. So on the other side, we have some newest data that draws a distribution area of different stocks that has been harvested in the North Sea and the Baltic Sea. So it's directly drawn from scientific surveys at sea. And then if we focus on the Western Baltic areas, then we can identify the main bulk of the distribution area for the main commercial species in these areas, so cod, herring, and sprat. And if we make use of very fine fishery data, what we can do is just to cross the VMS tracking data with declaration of logbooks, and then we can draw out of this the origin of the landings. So here it's mapping the landings. And to another picture to show you the heterogeneity that some fishermen go in some places and some others. And here is for the pelagic fisheries. So we have a full bunch of different species harvested. And obviously, if we start having spatial restrictions there, you will impact different fishing communities. So yeah, the DISPLACE application there was no, it's not DISPLACE application there. It's a static view of spatial restriction. So if we start implementing, well, it's already there, but if we start implementing new offshore windmill parks, such as this one, for example, folk sharing between Germany, Sweden, and Denmark, then we can, from the data, have some expert guesses about what will be the potential impact on these different fishing communities. And here, for different indices, for an example of indices is showing that the relative importance of the given areas in terms of total revenue. But if you plot the same thing, but this time accounting for the spatial dependency of some fishing communities on those particular location, then the picture is different, and then they are more impacted for some of the fishing communities. So, but it's only the static view there, and we would like to know actually if there is some ways for fishermen to compensate what they will lose in terms of fishing grounds. So for that we need actually we need a dynamic approach, because obviously we have an interlink dynamic between the stocks and the fishing activities, and this is in a feedback loop and projection over time. So that's why we go for a dynamic evaluation, and DISPLACE is basically doing this. So we have a Natura 2000 site in the western areas, and with different level of implementation. So we parameterize DISPLACE modeling for the 3 countries, so we share the data there, and then we conduct some scenario evaluations to see the effect on the vessel economy of these different spatial restrictions, and keeping in mind that we would like to achieve the sustainability of the harvesting for the 3 main commercial species there, but also looking at potential side effect of effort displacement on potential sensitive benthic habitats. So this is setting in a management strategy framework, and we will later on incorporate some trophic interaction between the main 3 species there. And then it's what we did actually, and then this is not an observed pattern, but it's a simulated one. So we simulated about 300 vessels there, and they are not allowed to fish in the spatial restriction, or they are allowed to fish with some non-compliance effect. So what we can draw out of this DISPLACE approach is, for example, landings maps. So draw the origin of landings as without restriction or with restriction, or different scenario evaluation about their potential reaction to tax or discard issue, and then we can directly draw actually the impact in terms of ratio of the available biomass, the harvested part over the available biomass. So, and then in order to identify potential depletion that can be a side effect of spatial restriction. And then so we have a bunch of scenarios actually, windmill farm, Natura 2000, or potential low production, shift in production of the stocks. And then we obtained some global figures about total effort, steaming effort, number of trips, average trip duration, and we can see that the main result of spatial restriction was to create longer trips at sea. Yeah. And we have consequences as well, some different indicators in terms of bioeconomic indicators, revenue, fuel cost, catch rate, how you alter these different indicators for the different bunch of scenarios, and also in terms of energy efficiency. So if we look at the individual consequences, we can draw some stress level, that's the proportion of vessels that will have a loss in profitability against that have some gains. So and then we can do it by fishing communities. Is just if they target different assemblages and try to identify who will be the losers and who will be the winners. So all of this is stochastic, so it's to handle the uncertainties there. So and then the common biological sustainability will be spanning stock biomass there, and for the different scenarios for the 3 species, what will be the potential effect and or future projection of the system, and then in terms of fishing mortality. But an important aspect is that you are likely to create effort displacement on sensitive habitats that are listing different habitats coming from the balance map balance projects that map some landscapes habitat. You know that better than me. But what we can do is to compute the cumulative fishery effort that will be likely on the displacement of this effort between habitats to see if there is any side effect of the spatial restriction there. Stable profit from compensation. So actually looking at the dynamic of the system, fishermen are able to compensate what has been lost, but we lose in energy efficiency. So in terms of fuel is not a good thing, because we are actually increasing the steaming time. And we have a potential positive global effect, and then DISPLACE should act as a support tool for fisheries and management for facilitating the understanding of the dynamics. And then we are about to extend it to an ecosystem modeling, including benthic habitats, resilience, and mortality on the benthos, and then accounting for different spatial heterogeneity in the underlying stock distribution. So last slide is about stakeholder engagement and how we can disseminate this tool to make it more profitable for fishermen and managers. So we just set up a very primary website about to communicate this, and then the approach will be actually presented to the Baltic RAC the next week, and then we will get feedback in an iterative manner to improve and redefine some points that can be obscure or not well managed right now. So thank you for your attention, and sorry for this.
Yeah, well, sometimes computers are tricky. Sometimes they can calculate a lot of different things for us. So they have advantages and disadvantages, as we all know. We have time for 2 questions. Keith was very quick.
Maybe I didn't quite get the point, but your speech was called How Spatial Planning Constrains Transnational Fisheries. I found that very intriguing. But I did not quite have the idea that the speech was should the speech have been called How Spatial Constraints Influence Transnational Fisheries? Because I did not see a role for spatial planning here.
Yeah, you think that the title of the presentation is not neutral. And then, well, I think we are talking about narrowing the fishing grounds. So fishermen will not be allowed anymore to fish in given areas, or will be restricted in somehow. So, well, I see your point, but I think that we are about to narrow their fishing grounds. That's for sure.
One more? You want to add something?
But as I said, on the medium or longer term, well, it's maybe not so important if they concentrate on areas that will have a higher catch rate, because of the stock will be made healthier actually. So on the medium term, the model is showing that
your point is new activities are constraints on fishery. But good spatial planning might, in effect, help to reduce those constraints. Wouldn't you say?
Yeah, well, spatial planning should be a solution, you mean, instead of constraint, but, well, it depends on the weight of your sector. I'm not sure.
Well, I guess at least as spatial planners, we need this type of knowledge to understand the impacts that we have with competing activities. So many thanks, Francois. Take rest after the stressful minutes. We'll stick to fisheries and adding aquaculture. And if you think about aquaculture, well, then of course you think about Norway. So